Right, we're looking at differentiation here. So differentiation, essentially, you just got to remember how, I'm not going to go through first principles and stuff like that. There is stuff in the book, I think, about that. All right, but essentially, differentiation is finding a gradient function. So the difference in y over the difference in x. Okay, so what we do with x to the power 4, so I'm going to differentiate each of these bits separately. I'll do them in a different colour, actually. So x to the power 4 goes down, so differentiates to 4x cubed. So the power goes down by 1, but you multiply by the coefficient of x to the power 4. Now, if I go to, I'm going to change colour to blue for the next bit. So this is plus, now 2 times 3, so I get 6, and then the power goes down by 1. So there is x to the 1, all right? But we don't tend to put the 1, do we? Okay? So that's how you differentiate that. That's a sort of fairly standard one. Now, second one, you need to rewrite this as this using negative indices. Minus 5x to the minus 1 plus 1. Now then, again, we're going to differentiate each part separately. So dy dx equals, so I'll do this one in red and I'll do the next one in blue and stuff. So minus 2 times 7, negative 14. And then the power goes down by 1. All right. And then, hold on, to change colour. This bit, minus 1 times minus 5 is plus 5x to the minus 2. Now, this plus 1 here, okay, on the end, which was there, okay, that just moves the graph up and down. It doesn't affect the gradient. So actually, when you differentiate just a number on its own, okay, that just disappears. It has no effect on the slope of the curve, right? Whereas the parts with the variables in does. Okay, so that's that one finished. Okay, so we're going to calculate the gradient, because what dy dx is a gradient function. Okay, so I'm going to get this. Oops, sorry, made a mistake. There we go. So going to get this here. So x cubed goes to 3x squared. Power of x goes down by 1. And the old power we multiply by the coefficient at the front. Right, 2x differentiates to 2 because x to the power 1. It goes down to x to the power 0. And anything to the power 0 is 1, isn't it? So that's just 2. Now, the minus 4 disappears. That just moves it up and down again. Okay, now then, this is the crucial bit. Calculate the gradient of y, of that function, y equals x cubed plus 2x minus 4, all right, at minus 1, 2. So I've got x's here. So I'm going to put, actually, I'll do it in a different colour. That's a better idea. Here we go. So different colour. I'll do it in green. So this is my x value I'm going to put in to here. Okay, for the x. So I'm going to get 3 times minus 1 squared plus 2. Now remember, when I square minus 1, I get 1. So I get 3 plus 2, which is 5. So the gradient of that curve at that point is 5. Okay, so dy dx at x equals minus 1 there. Okay, don't put the y coordinate in, you don't need to. That's sort of second year A level stuff. Okay, now then, the last one, work out the rate of change with respect to x. Now, the rate of change is essentially exactly the same, all right, as just differentiating. That's what it is. A gradient is a rate of change. Okay, now, when I look at this, okay, that's horrible. Or well, it's not horrible, but it looks pretty horrible. So what I'm going to do is I'm going to put everything on its own fraction, like this, over x. And then I'm going to rewrite it. Okay, so 2x cubed divided by x is 2x squared, isn't it? 5x divided by x is just 5. And, oops, that should be a minus, not a plus. Okay, and then minus 3 to the power x minus 1. Okay, differentiate that, and we've got all the skills to do that. We've done that already. So the first one, I'll do this, goes 4 to the power x. 5 just moves the graph up or down, doesn't it? Doesn't affect the gradient, so that differentiates to nothing. And then I'm going to differentiate this one, which gives me plus 3x to the minus 2. Now I could rewrite that as 4x plus 3 over x squared, just like I could have done up here. All right, to minus 14 over x cubed plus 5 over x squared if I'd have wanted. All right, but you don't have to. Anyway, hope that's fairly clear now. Enjoy.